Welcome back. Let's talk a little bit more about Lab 2 because you need to answer a very important question on number 2 regarding z-scores. I want to show you a complete analysis of the data that connects all of the chapters, all of the sections in chapter 3. So for the lab 2, I was using continuous data, and this was my data set, which was the heights of all the students in inches. And from my video, you saw that I did calculations, and I got some of these basic calculations like mean, standard deviation, median, mode, and I also had this 5-number summary and the IQR. It's easy to answer question 4 just by comparing the mean with the median, and you can see mine are fairly close, so that tells me that my data is probably fairly bell-shaped. But I can also double check that and make sure that I don't have any unusual data to answer my question number 2. So what I'm going to do first is I'm going to take a look at the empirical rule. I know by looking at the empirical rule that if something is bell-shaped, then the mean would be perfectly in the middle, and in my case, the mean is 66.92. And then the standard deviation, we're going to go out 3 standard deviations, and that's going to cover about 99.7% of the data, or almost the entire data set. So my standard deviation is 4.46. So I'm going to use a calculator and go 66.92 plus 4.46. That's going to give me 71.38, so that goes right here. Plus another 4.46, that would be 75.84. Plus another 4.46, that's 80.3. That's how far I'm going to the right. Now we're going to go to the left. We're going to go 66.92 minus 4.46, right? So 4.46, let's see. Yes, we're doing good. And that would be 62.46, 62.46 on the left, minus another 4.46. That's going to give me 58. And minus another 4.46. That's 53.54. So according to my empirical rule, or to the empirical rule with my mean standard deviation, this is how it's going to change. Let's see how as my data gets affected here. I'm taking a different color pen. 58 is my lowest, so 58 is about right here. And 74 is my highest, so 74 is about right here. I am within 2 standard deviations, if you can see, 1, 2, 1, 2, of the mean, which is a good thing, because according to the empirical rule, within 2 standard deviations, you cover 95% of the data, which is the majority of your data set. That leaves 2.5% in the tail beyond 2 standard deviations, or 5% total, 2.5% here and 2.5% here. Now, if any of your data falls beyond 2 standard deviations in this 2.5% range, well, that makes it unusual. Why is it unusual? Because there's only 5% chance that it could be there, and 5% is not very convincing. So that makes it unusual. How about beyond 3 standard deviations? Well, if anything is beyond 3 standard deviations, that's almost impossible, because within 3 standard deviations, you cover 99.7% of the data. So outside of 3 standard deviations, you have what, 0.7% of the data? That's a very small percentage. So if anything falls outside of 3 standard deviations, they are probably outliers, and you have to pay extra attention to those values. So again, shaded part is unusual, and then red shaded part is unusual, and the green shaded part is outliers. Pay attention to those. In my case, My data is within 2 standard deviations, which kind of proves that it's bell-shaped. I don't have any unusual or outliers. So according to empirical rule, I'm doing pretty good. Now, let's take a look at 5-number summary. So here's my 5-number summary right here in front of me. I have the minimum, the Q1, the Q3, the maximum, and the IQR. So these numbers tell us about our data in terms of position. So what I'm going to do here is I'm going to calculate the fences, just to see what my data looks like according to fences. So the lower fence should be calculated by using formula Q1 minus 1.5 IQR. And the upper one is Q3 plus 1.5 times IQR. So we're going to calculate the fences by using this formula. So in the lower case here would be 63 minus 1.5 times 7.5. And for the upper would be 70.5 plus 1.5 times 7.5. So using my calculator here, 63 minus 1.5 of 7.5, that's 51.75. It's my lower. And 70.5 plus 1.5 of 7.5, that's 81.75. So back to my data here. Here's my data. It goes from 58 to 74. My fences telling me my lower and my upper right here is 51.75 and 81.75. My data, taking a green pen, goes from 58, which is inside of the fence, to 74, which is also inside of the fence. Everything that's inside of the fence is okay. Anything outside of the fence is questionable because it probably has some kind of a problem with it. You can see again, just like empirical rule, my fences show me that I don't have any problems with my data. It's nice and bell-shaped. If you find something outside of the fences, you have to take a close look at it. What do we do with the numbers that we find to be unusual or outliers according to empirical rule, or outside the fences according to our fences rule? Well, we look at them by using a z-scores, because z-scores tell us exact the location of that value, and it exactly points out to us if it's unusual or an outlier and why. The z-score is calculated by using the formula value minus the mean divided by a standard deviation. So for example, let's say I want to calculate a z-score for 58. That's my lowest data value. What I'm going to do, I'm going to use the formula, put a 58, my value, minus my mean, which is 66.92, divided by the standard deviation, which is 4.46, equal. Do the subtraction first, please, because it's not going to work properly. 58 minus 66.92 divided by 4.46. I get -2. What does it tell me? That tells me that 58 is exactly 2 standard deviations to the left, which we already knew that because it was exactly at the second standard deviation on the empirical rule. So is that a bad thing? No, because it's still within a 95%. Now, if it would have been above 2 or below -2, it would have been unusual. If it would have been outside of 3 standard deviation, it would have been an outlier. And of course, in that case, you're probably not going to have a bell-shaped distribution. The shape of your distribution will follow the outliers or unusual data. It's either going to be skewed right or skewed left, or possibly will balance out between the two. So this is the complete analysis of the data that helps you to see everything that could possibly be wrong with your data set. So if you complete this type of analysis, you'll be able to answer nicely your question number 2. You'll be able to point out why or why not you have any unusual data or outliers and what their z-scores and how it compares to the empirical rule or the fences or the z-scores. I hope that helps you with any of the questions you might have, and good luck getting it done.